This is problem 4 in our review of probability. In a budgeting website, it was reported that 25% of U.S. households have withdrawn money from a 401k or other retirement account for needs other than retirement in 2013. In a random sample of 11 households, we want to calculate the probabilities of a few things. First, in a sample of 11, what is the probability that exactly 3 households withdrew funds from a retirement account? So if we look at this, each of the 11 people that I look at have a 25% chance. And so we're assuming that this is a random sample, in which case the probabilities are independent of each household withdrawing money. So we're looking at a fixed number of observations, n equals 11, a fixed probability for each of the observations of 0.25, the probability that they withdraw money for something other than retirement. We're assuming that all 11 individuals are independent of the others. So what we're looking at here is something that's binomial. So to calculate these probabilities, I'm going to use the binomial distribution where n is 11 and p is 0.25. So let's go to StatCrunch. I'm going to bring up my calculator for the binomial distribution. And so I'm going to put in n equals 11 and p equals 0.25. And I want to calculate the probability of first exactly 3. So we'll say equals, that pull down menu is kind of off your screen. So let me say equals, not 5, but 3. Compute. You notice that the bar at x equals 3 is marked in red, and that probability is 0.2581. So the 4 decimal places, let's put the probability in as 0.2581. Part B, what is the probability that less than 4 households withdraw funds? So less than 4, so I'll choose less than and enter 4 and compute. And so less than 4 doesn't include 4, it's less than 4. So the possibilities there would be 3 households, 2 households, 1 household, or 0 households. And if I add up the probabilities of those red markings there, I get 0.7133. So we'll put in for part B 0.7133. Part C, what is the probability that more than 5 households? So I'll say greater than, and then I'll change this to 5 and compute. So greater than 5 means 6, 7, 8, 9, 10, or 11 households. And so if I add those up to 4 decimal places, I would end up with 0.0343. And then part D asks for the mean and the standard deviation. So let's recall the formulas for the mean and the standard deviation for a binomial random variable. So what I have here for binomial distribution with n equal 11 and p equal 25, the mean, which is n times p, would be 11 times 0.25, and the standard deviation would be the square root of n times p times q, or 1 minus p. And so what I'll do here, let's calculate that. So 11 times 0.25 gives me a mean of 2.75. And then if I take the square root, so second x squared the square root of n 11 times p, which is 0.25, times 1 minus p, and 1 minus 0.25 is 0.75. I end up with a standard deviation, it says rounded to 4 decimal places, 1.43 6, 1. So that's my mean and my standard deviation. Okay, so now let's consider the distribution and its graph. So if I look at the graphs I've been looking at in StatCrunch, this right here is modeling that histogram. The only thing is I'm not using bars, I'm using needles because the probability is concentrated at 0, 1, 2, 3, 4, and so on. And so if we look at the distributions that they have here, these histograms, the one that's modeled best here is part A. If you want, you can blow that up. And you can see 0, 1, 2, 3. You can see 2 and 3 are the same probability. And so that would be our choice, part A, or graph A. Okay, so that's using the binomial distribution to find the probability of being exactly, greater than, less than, and you can change that around a little bit. There is the between option that would give you the probability of being between 3 and 6 inclusively. So I hope that helps.